Hey guys, in this video we're going to be talking about pre-trained models in PyTorch, and we're going to be talking about what pre-trained models are, why we like to use them, and we're going to be going through a few examples of a few of the most popular pre-trained models out there. Okay, so let's get started, shall we? Okay, so we're going to be talking about pre-trained models. Okay, so pre-trained models. Let's first start off, let's take a step back and really appreciate the amount of data that we have at our fingertips, like today, okay? In this current day and age, we have tons of more data than we used to have. We have extremely large data sets, and nowadays there's a bigger need to classify and interpret the data that we have. And I was thinking more of images right now. There is also natural language processing, and we can go through audio data, video data, but in this video, let's just stick to the example of computer vision and analyzing images, okay? And pre-trained models are just models that you can download and run, and they've been developed by other people. And most of the popular ones were developed by some of the best researchers out there. And these models have been trained on open, which are just like public data, open data, right? So you don't need to design the model yourself, or you don't need to train the weights of the model yourself, okay? The researchers already took the time to design the model for often it's not one specific purpose, because you can use that model and fine-tune it to your own project that you're currently working on, right? So you can use someone else's model and you can apply it to your own work just with a little, just fine-tuning a few things. Okay, so you can use the work of some of the best researchers out there. That's what the main idea is behind pre-trained models. And you can use anyone's pre-trained model. It doesn't have to be like some of the best researchers, but those are the most popular models out there. Okay, so like I said, again, we're going to be focusing on computer vision. And there are a few popular pre-trained models in computer vision, and they mostly have different purposes, but I can think of three distinct purposes that they mostly work for, right? So we can have image labeling. So these are the different purposes for these pre-trained models in computer vision. Okay, so, or any models in general, rather. Okay, so image labeling and classifying. Okay, you can also do some image generation. So, and based on another image. So you can generate and synthesize your own image based on another image that you're looking at. And the last main type of thing you would use these models for is to maybe describe what is going on in the image, using language, right? Using English sentences. Okay, so for example, if you it's just like image captioning, right? So you have a little caption underneath an image to describe what's going on in the image. Okay, cool. So another thing I wanted to talk about is that the researchers who develop these pre-trained models, they often publish source code on a repository along with their papers, and like these models have the weights that they trained on another data set, and this data set is often it's usually pretty large, so that you can use it for multiple different purposes and multiple different projects that you would like to work on. So it's available to everyone, and everyone has unique projects that they're working on. So you can probably apply it to your own work too. So that's why like you can use this you can use the model that someone else trained, right? A pre-trained model. You can use it without too much work on your part. Okay. And one extremely large, extremely famous data set is Stanford's ImageNet data set. And this data set has over 14 million images. Okay, and we'll be looking at a model that was trained on part of the data set. Okay, and so these images are labeled using Princeton's WordNet. And just to give you some historical / background information and context, the ImageNet data set started off and grew out of like the ImageNet Large Scale Visual Recognition Challenge. It's a competition. You can abbreviate it as ILSVRC, and it began in 2010. And these challenges that took place in this challenge that I'm talking about is like, they include image classification, object localization, which just tells you, like where the object is in the image. So if you have like a cat in the image, it would tell you where it is. And object detection, scene classification, and scene parsing, which is just, like partitioning the image into different areas which are associated with different labels and classes. And I'm using labels and classes synonymously, so they mean the same thing. So for example, if you had an image of a park, right, you would have like maybe some swings in there, trees, and like a bench maybe, and each of these different objects are different classes. They're different items and different labels, categorical values associated with the objects, right? So it would partition the image into different areas depending on which object we're looking at. So maybe the trees would be blue, and maybe the bench would be red, and maybe the swings maybe would be yellow if that's what we were looking at. So yeah, those are the different challenges that were included in this competition. Okay, so yeah, that's enough background information. It's kind of fun to learn about and see how this all came to be, Okay, so let's talk about using these models, right? So the most popular models you can import from Torch Vision. So you can say from Torch Vision, import models. Okay, and if you want to access it, you would say dir, right, or directory, and then models. Okay, and then you'll see a list, okay, of a few of the best pre-trained models, and I cannot stress this enough. They're the best. I would definitely recommend checking them out and see if they apply or if they're applicable to your own work or little side projects or whatnot. Okay, but this is a list that you're looking at here, and you see some start with a capital letter and some don't. So what's the difference? Well, the capital letters stand for classes, right? So these are all classes. If it starts with a capital letter, then it's a class. And the lowercase ones are instances of the class. So if you're familiar with, object-oriented programming and like having an object of a class, right? It's just an instance. It's an example. For example, if you had like a if the class was food, and you would have maybe different instances of food like mac and cheese, pizza, or spaghetti or whatever, okay? So those are instances. And so there are differences between the different instances, right? And so you can see this if we were taking a look at ResNet. Okay, ResNet is amazing. It's a pre-trained model, but there are different like instances of it. So you see ResNet 101, you see ResNet 152, 18, 34, 50, right? So these are like the number of layers that each of these instances have. So each layer of a neural network, and we'll go into a deep dive into what is a layer, like what are layers, and what each of the layers do, how it's related to the computation. We'll go into that in another video, but all you need to know is that these are each one of these instances have predefined layers and units, and they are different from one another, so you can choose whatever one you want to use. Okay, so another piece of background / fun facts, or fun fact, right, is that Alexnet, you see Alexnet up here. Alexnet won the 2012 ILSVRC, like that, it's a mouthful, but it won that competition in 2012, and really it showed the potential for deep learning. And I know there are other areas in deep learning like natural language processing and like these other things, but it was image recognition and dealing with images that really showed the world the potential of deep learning and the potential of like these different innovations that have been coming about recently. Okay, so yeah. Okay, so let's take a look at the Alexnet. So let's create an object, okay, and let's just call it Alexnet. Okay, let's call it Alexnet, and it's part of models, right? That's what we imported, and it's Alexnet. Oh. Alexnet. Okay, and I'm not going to pass in any arguments right now. Okay, so it'll just stick to the default. Okay, whatever that is, or whatever they are. Okay, so Alexnet is an object, and it's an object that can run the Alexnet neural network architecture. Okay, so whatever features, whatever characteristics and attributes and whatever functions and whatever like amazing stuff that our Alexnet neural network architecture has and possesses, our new instance / object of it can now be used to access those great things. Okay, and so if you pass in an input that's obviously the correct size, and let me talk about let me just mention to you that if you have an image, if you have an image, like if you have an input image that you're passing in to your model, you're going to need to convert it to a tensor, because once again, your model can't just take in images directly, it can't take in paragraphs directly. You need to convert it into a form that your model can understand, and that form happens to be numbers, and we have a core data structure for that, which are tensors. And in our next video, we're going to be talking about tensors, and we're going to deep dive into that topic, okay? We're not doing it now, but the input you're going to need to convert to tensors, okay? So they can either be vectors or matrices, okay, which our model can work with. Okay, so yeah, that's just what I want it to add there. And if you pass in an input with the correct size, which just means like with the correct dimensionality of the tensor, it has the right dimensions like 0, 1, 2, 3. You can use indices to reference them. But if you pass in an input of the correct size, it will make a forward pass through the model and through the layers. Just think of it as sections of your computational like web, okay? There are different parts and different sections, and you can choose which sections you want. So those are like different layers / modules in PyTorch. Okay, so it'll make a forward pass through the model. Okay, and forward pass is just like if you have like a set of inputs, it's gonna run through this first set of neurons, and then you get an output, and then that output is the new input for the next set of neurons, and so on all the way to the final output. So it's like the first run, or like not the first, but like any run through the model, you can call a forward pass. So that's where all the computation happens. Okay. So the interesting thing here is that the weights haven't actually been trained on anything. So we have two options here. We can either train it ourselves, or we can use the pre-trained weights that we've been talking about, and we can use the hard work that the best researchers have put in to training this model and getting the like perfect weights. And I'm not going to say perfect because there's no such thing, right? But like the weights are very like accurate, and so that would be the best option. Okay, so using the pre-trained weights, unless you're doing something drastically different, like you can train it yourself, but like it would be best to stick with the pre-trained weights, at least for our learning purposes, right? So let's run this, and okay, models. Okay, great. Okay, so we didn't pass anything in, right? But we have two choices. Let's try a new choice. Let's try our second choice with ResNet. Okay. So first we're talking about Alexnet, right? Next, let's talk about ResNet. Okay, so we're gonna do something extremely similar. Okay, so let's just use a ResNet. Let's create our ResNet model. Okay, so models.resnet. But you see Alexnet, there's only one thing you can choose from, one instance you can choose from. But for ResNet, you can choose like many different layers and units. And let's just stick with maybe instead of ResNet, let's try ResNet 101. Okay. Okay, so it's gonna be ResNet 101, and we're gonna pass in one argument, and we're gonna set pre-trained equal to true. Okay, and it's gonna take a while. So what it's doing now is that it's downloading the weights right now. And so weights are just like how much importance you give to a specific feature or attribute. So for example, if you were working on like a weather application, right, that can tell you what the weather's like outside, and you have like different features like the temperature, the humidity, and one bizarre thing like the color of your shirt, right? So they're gonna have different contributions to the weather, right? Like I think the temperature and humidity are going to contribute more to the weather than your red shirt is, right? Or blue shirt or whatever. So if a feature or attribute has more importance to the outcome, then it would usually have a larger weight. And a weight is just something you multiply the input by. And remember, the input you're converting to tensors. So your input is just numbers, right? So you can multiply them by whatever you want, right? So if you have an image, you would have like pixels, right? And maybe you would take 1 pixel, and this, you wouldn't actually deal with 1 pixel. I'm just giving you an example. But if you had like an input X, if you multiply it by a number, just like as a part of your computation, that number would be the weight. And depending on what importance it has or what significance it has to the outcome, it would be either larger or smaller. Okay, so what we did now, once again, is we downloaded the weights, and the weights that we have right now for our ResNet are equal to the optimized ones of the pre-trained model. Okay, so whatever researchers or whatever people train the model, right, they have certain weights, right, or parameters. Right, and the parameters can get crazy. They're not just going to be weights and biases, right? Because we're adding in nonlinear things, and so we're going to have tons and tons of parameters, but we don't need to worry about that now. It's just different parts of the computation, and we're downloading, and you can change the values. And so these are the perfect or close to perfect values that you can have for your model, and we just downloaded them right now. Okay, so let's take a look at our ResNet. So you see the ResNet here, now that we printed it out, and you see some different layers. Okay, you see like a convolutional layer, you see many actually, and you see something called a bottleneck layer, right? You see 101 to be exact, right? Because we have 101 of these bottleneck layers. And what we're seeing here is ResNet's architecture. So what does ResNet look like? What layers, what modules actually? In PyTorch you call them modules. In other deep learning frameworks you would call them layers. But once again, they're just sections of your computations. Okay, so you have a ginormous web of computations. It's pretty large, and we break it up into sections. Okay, and so when I say module, don't confuse it with Python modules. They're just layers and sections of the computation. Okay, and each of them have a collection of operations and many different computations that go on in these modules / layers. Okay, and so here in ResNet 101, there are 101 bottleneck modules, and these are basically just a series of filters and non-linear layers, or functions rather. It's all math. I can't stress this enough. It's all math. Okay, so when I say layers, I just mean like a different set of functions, and they each have a different collection of operations, like I said. And the last layer that you'll see here is actually a little different. So you see FC, and what this is that this layer, this set of the computations, this ginormous set of computations, actually produces scores / probabilities for each of the different classes / labels, and how likely they are to be the input image. And so what do I mean by that? What do I mean by the fact that this last one produces different scores and probabilities? Well, if we have a classification model, okay, so the purpose of this model, this like mathematical model is to tell you whether an image is a cat or a dog, right? The standard cliche thing that everyone starts off with, right? So is it a cat or is it a dog? Or maybe let's add in a few more animals like an elephant or a turtle or a giraffe, right? So each of these different categorical values, right? Each of these different labels, like elephant, like turtle, like giraffe, cat, dog, each of these are different classes. And our output is going to have the same 5 classes as like our output, except for each of those 5 different classes, our output is going to be producing a score and probability for each one. So if our input image was a dog and you pass it in, and the model's familiar with all the other animals, right? Because those are the classes. But our output, if we pass in a dog, our output will have 5 different numbers since we have 5 different animals, and the dog would probably have 0.95. Cat would probably have like something lower than that because it's like the highest probability that it is a dog, or it's the most likely that this input image is a dog, so it's going to have a higher probability. Okay, so yeah, that's that. And there is some pre-processing that would have to go with it, but I'm not going to go into the pre-processing today. We're going to continue with our ResNet, and we're going to do some pre-processing, which has to do with like some transformations, and just to make sure that it's the input image, which once again we convert to a tensor, we need to make sure that it is the right number of color channels. So if you have an image that's color, so it has like, it's probably an RGB, so it has 3 different color channels, and so maybe that would be like the first dimension, and then you would have like the height and the width. So just to make sure that everything's in check. Okay, so we would apply some transformations, and Torch Vision has some tools that allow us to do that. Okay, and so that's what we're going to be doing next time. Okay, so what did we talk about today? Well, we talked about pre-trained models. We talked about the history behind them, like ImageNet, like Stanford's ImageNet, 14 million plus images, and it's labeled, and you can use these models with the simple import statement, and you see a list of all the models. You know that these are the actual classes. And remember, neural networks, like, they're not some magical thing. They're just like, they're classes, right? Like Python classes, and you can you can write your own if you wanted to, like how you write your own Python classes. You can like make a simple like custom model if you want, just adding a few different layers, and but here are a few of the best pre-trained models, and these are the different instances of them. Okay, and we looked through Alexnet and ResNet and saw how we can use these pre-trained weights. We downloaded them, and we just set a simple argument equal to true. Okay, and we took a look at the architecture of ResNet. Okay, so that's what we did today. I hope you learned something new, and I'm looking forward to seeing you in my next video. Thank you so much, and have a great day.